All right, so today we're going to do a little intro to brakes, specifically disc brakes. That's the part we're going to focus on. There's another kind called drum brakes, which we'll talk briefly about. It's kind of gone the way of the dodo bird, thankfully. I mean, they were fine, but disc brakes are so much better stopping. And so most cars now are disc brakes all the way around. We will run into some that have drums in the rear. And then you'll see the occasional old pickup or something that will come in that has drums all the way around. When that happens, you get to do a drum brake job. Woohoo! All right. But until then, pretty much going to focus on disc brakes. Excuse me. So on a disc brake system, you have a few very important situations here. First of all, you'll have the disc itself. Okay? And then it's mounted such that these are your lug nuts sticking out, your lug bolts sticking out. This is the disc. And then over the top of that, you'll have some pads on the front side and the back side of this. And then what we're going to do is we're going to clamp those down. So viewed from the side here, you're going to have a brake pad here and a brake pad here. And we're going to push inwards on it like so. As the rotor is trying to turn, we're going to stop it via friction. So one can see that if, friction, obviously what do you got to go get? Steel versus these pads. These pads are made out of this friction material. If you ever got any grease on those pads, that's not great. Mr. Groom, we leaked some brake fluid on those pads. Yeah, it's not great. No. Water, not a big deal because water will boil off, like immediately. So, yeah, immediately. When your brakes start dragging, those rotors will get hundreds of degrees hot, like hundreds of degrees hot, and it will boil the water off instantaneously. So we're not worried about water at all, really. I say not at all, but I mean, for the most part, we're really not worried about them at all. Okay. So the only question is, well, how do we get them to squeeze in? Okay. So that's kind of what I want to focus on today. It's kind of how the gist of this thing works, how a brake system works in general. And just kind of watch this little video today. Then over the course of the next week or so, we'll have a few demonstrations live in the classroom on cars. Mind you, I still this week have to get done with all of the oil changes. So this is an intro. And we'll kind of see where we go with this. Okay, so the game is thus. We have what we are referred to as hydraulic brakes. Whether they're drums, whether they're disc brakes, doesn't matter, they're hydraulic brakes. What does that mean? Well, just like a hydraulic jack, actually. So, on a hydraulic jack, okay, we have this piston. It is free to move in this cylinder. You with me? There's a cylinder here like so, like this. With a little tubey tube. And I've drawn this picture for you before, or one very similar to it. Here's the little piston. Here's the little itty bitty piston, Mr. Groom. And attached to your handle. Whoop. And when you push down the handle, you push fluid. The fluids are incompressible. That is, you cannot compress a liquid. Therefore, when I push down on it here, that fluid has to go somewhere. It comes into here. Okay? Why? Because I'm applying pressure to this piston. Pressure creates a force pushing downwards. That same pressure is transferred everywhere inside the fluid, in every direction. That pressure pushes in every direction, the same pressure that I push down. It goes everywhere. Well, what ends up happening is this fluid then moves over here, and then, of course, this is, some fat guy. Whoa, I'm a giant fat man. All right. And he gets lifted upwards because, obviously, that piston can move. Does it go up very far? No, it doesn't go up very far because the amount of fluid that you moved over here in this big fat cylinder, in other words, remember it's pi times the radius squared. Well, actually, we'll do it this way. Pi times, just like we did pi times the diameter, or pi times the bore, squared divided by 4 times the height. On this side is equal to pi times the bore squared divided by 4 times the height over here. Now, clearly, the bore over here is a lot bigger. So, for instance, let's throw some numbers at it. Let's say this had a 4-inch bore, and this had a 1-inch bore. All right, cool. And so for the first one, it's pi times 1 squared divided by 4. And then let's say you move this sucker down 4 inches. Nice. Awesome. All right, that means that you moved 1 pi cubic inches of fluid. Okay, on the other side, it'd be pi times 16 divided by 4 times h. These things have to be the same. So pi 4h. H. You see that? Hey, the h's cancel out. They sure do. So h would equal 1/4, right? It's going to go up 1/4 of an inch. And so, but the result is that with a smaller amount of force over here, because obviously I cannot lift that big guy, when I push down this lever, I force this piston down, and I take that pressure that I put on this thing, and I push it up on this side. Okay? Big deal. Huge concept, okay? Because I cannot physically push down very hard a force over here. Pressure is equal to force over an area. Okay? So, bless me. Woo! The reason that I am able to put some force to this thing is I have some pressure rather, is because I have a pretty small area that I'm acting on. Okay? I have a pretty small area right here that I'm acting on this piston. Okay? So I generate some amount of force. Nice. And so on this other side, the pressure here is the same as the pressure on the other side. Whoa, Groom, that's crazy. I know, right? And so, for instance, if we had a downward force on this, let's say that we were on the little piston. Let's say that our area was, well, our area is pi times the radius squared, right? And then a force on top. Let's say I'm pushing now with 50 pounds of force. Then this would be, let's say we had a 1. Let's say it was a 1/2 inch. Okay, let's get some math out here. I need some math. 50 divided by pi times, it's 0.5 squared, times 0.5 squared is roughly, oops, that's not 550, that's just 50. So I'm applying about 64 psi here. 64 pounds per square inch. Pounds per square inch. Or in other words, 64 psi. Okay? That's awesome, Groom. Can you explain what that means to me here? Well, yeah. So that same amount of force works on the other side, yes? Mm-hmm. And we can actually see that if you do 64 psi is equal to, all right, cool, what does that mean to me? Well, I have a larger area, and on a larger area over here, it's going to be equal to, let's say, pi times 2 squared. It's about 12.56. 64 is equal to F over 12.56. What does that do for me, Groom? Well, I'll tell you what it does for you, bud. Is then when you solve that, you find that the amount of force that you can lift is about 804 pounds of force, right? And that's why we do that with the brakes, or rather with the jack handle, right? And like, what does that got to do with the price of tea in China, Groom? Well, because in our car, we have a brake pedal that hangs down. Yes? Hey, that brake pedal looks a lot like what? Looks a lot like the lever on my jack. Yep, sure does. There is a linkage that comes out like this. Now, we're going to talk more about this part. I'm going to leave a part out of this for now, okay? But later on, I'm going to bring it back up. Inside of here, there is what we call the brake. It's called the master cylinder. Wait, does that mean it's a cylinder? Correct, sir. Wait, with a piston inside? That's correct. Whoa. And when I push this pedal down, it forces the piston in. That's correct. That's correct. Whoa, that's awesome. And it has this brake fluid reservoir on top. Brake fluid. Mm-hmm. And when you push it down, it forces fluid out to all 4 brakes, front and rear. Okay? And yeah, that's the game. And you're like, that's it. That's it, bud. Now, unlike your unlike your, come on, Jay, use your words. You can do it. Unlike your jack, I don't want this thing to stay locked. Yes, I want them to come back and let off the brake. So inside of here, there's a spring, right? And so when you let go of the pedal, the spring pushes it back out. And what happens to that? Well, all the pressure releases from the brakes, and your brakes release. That's it. It's as simple as that. Okay. Again, this thing here is called the master cylinder. It's in the engine compartment on what we call the firewall, which is the back wall of the engine compartment. It's called a firewall because it's supposed to keep, in case there's any fire, keep it outside, away from you. Okay. Anyway, so this thing right here is referred to as the firewall. Anyway, yeah, that's where it's mounted. Now, we'll talk more later on about how, Mr. Groom, aren't you missing something? I am, but we're not going to talk about it too much right now, other than to say that on most of our on pretty much every modern car, there's what we call power brakes. And so we have a vacuum system from the engine that we harness in order to make it easier to push the brake pedal. Especially if you're a little person, especially in the old days with drum brakes, it was really super hard, and I mean really super hard, to get those things to work properly if you're a little person, because you had to physically do a ton of pushing to get them to stop. Okay. Now, out in each wheel, we have what are referred to as calipers. So they look kind of like this. This is an approximate, so don't go home tonight. Groom drew it looking like this. Isn't he a crappy artist? You all know I'm a crappy artist, sir, ma'am. Okay. Whoa. Is that a piston? Sure is, Groom. Whoa. Wait, is this the brake rotor? That's correct. Oh, crap. Oh, dang it. Whatever. Okay. This whole thing is referred to as the caliper. Okay. Why? Because, Groom, it looks like a caliper, and when you're pinching it, you're measuring like you're measuring. Exactly. Now, what happens is this. Okay. There's a line that comes from your brake master cylinder to master cylinder. And that fluid comes into here, and what does it do? It pushes this guy out like so. Okay? And it forces that inner pad. This is the oh, Mr. Groom Drew forgot. I knew I left a little room for something there. Hang on one moment, please. And then here is your brake pad. I'm going to make it a different color. This is your brake pad. And now here's your rotor. Mr. Groom, you messed up my beautiful picture. Do you hate me? Well, obviously. Duh. I mean, duh. Obviously, I hate you. And then, on the other side, you have another brake pad over here. Okay? Now, here's where it gets a little funky, a little weird, a little interesting. Okay? We, in the U.S., pretty much all cars anymore, use what are referred to as floating calipers. Calipers. Okay? As this piston pushes in this way, the back of the caliper moves this way. Does that make sense? And when it moves this way, what happens to this? This pulls over this way, which does what? Pulls the outside pad in too. Make sense? This is outside. Also referred to as the outboard pad. Outboard pad. This would be the inboard side. This is on the inside of the car. Okay? So the caliper piston part was always going to be on the inside of the car. With rare exceptions, like some older Corvettes had a setup where they had pistons on inside and outside. There's some other cars similar to that, like more of racing style pistons. But for the most car, like 99.99999% of cars will have the pistons inboard. Okay? Cars and trucks. Some of your bigger trucks will have multi-pistons. In other words, they have such big rotors. Whoa, look at that massive rotor, Groom. It's huge. I want to use a ginormous pad on this thing. That makes sense. But like one piston in the middle is not going to do a very good job. Cool. Let's do dual pistons. So same setup as this caliper, yes, except 2 pistons. The big deal? No, it's all the same, bud. It's all the same. Could you do 3 pistons? Yes. Who would have those? Racing cars, maybe. Okay. A lot of trucks now, a lot of bigger trucks have dual piston calipers, we call them, on the fronts. By the way, fronts do about 65-70% of your braking comes from the front, depending on the car, depending on the load, depending on a bunch of things. In a pickup that's empty, it's probably closer to 70%. Okay, if it's in a pickup that's loaded, like way loaded down, it's not going to be nearly as much. Maybe 55-60%, depends on how the load's distributed and stuff. Okay, it's just how it is. Obviously, when you come to a stop, the front end, all the weight shifts forward, and yours already more weight on the front anyways. It's going to do most of the weight of the braking. So your front brakes are always going to be bigger than your back brakes. Always, 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 always. Okay? All right. One moment, please. Something else to think about, and we're going to talk more about this as the time comes along. Your brake pads are going to be mounted onto a metal piece, and then the friction material sticks out on the front side of it like this, okay, if you will. So this is the steel backing, we call it steel backing plate. It's glued on. This friction material is glued on. In the old days, it was riveted on. But glue actually holds it on there, which is mind-blowing if you think about it. I try not to think about it. It's one of those things where, yeah, it should work. But if you think about it, you're kind of like, well, that seems cheesy. But there it is. From the factory, these are approximately 10 to 12 millimeters thick, which is about a ½ inch. If you want to think about it in that terms. Okay, so when a car comes in, we're going to practice eyeballing. I don't believe in taking a tape measure to it. I do not believe they make a little gauge of a thing you can jam in there. I don't believe in that. I believe you teach kids how to do it right, and then you figure it out. So if it came in and there was about 4 millimeters of thickness, we'd say that's about 40% brake pad life. Okay. Well, if there was 5, Groom, well, 5 out of 10 is 50%. You see this? And we always tell a customer, look, it's about 50%, about 90%, whatever it is. Okay, we like to change them. We get down around the 20% range. When we get about 20%, we like to go ahead and change them. Here's why. Not because I feel like they're going to die tomorrow. And not necessarily because I feel like anything. I just know that, hey, when I get down about 20%, I know what's going to happen. This guy's only here today because, we're doing his oil change, and we checked his brake pads for him. He's clueless about his brake pads. And the next time he comes in, it's going to be the next time he does his oil change, which is probably going to be later than he should be getting his oil change. And at that point, he's going to have a problem with his brakes. And so we want to make sure we change them about 20%. Yeah. So when you start thinking about that, you're like, oh, we better start telling the customer these things. So we're going to start eyeballing what the pad thickness is when we do it. We're going to be like, oh yeah, nice. That's about 10%, 20%, whatever, 15%, whatever it is. There's a lady a few years ago, and she came in, and I told her, listen, your fronts need to be changed, and we changed them. I said, the backs are about 50%. She's like, oh my goodness, shouldn't you change them? That's an F. And I went, oh, for gosh sakes. I said, no, crackhead. I said, turns out 50%. I said, for instance, at the time I was 50. I think I was 50 about that time. And she said something, and I said, listen, lady, I said, I don't even have 50% of my life left, because she's about my age. And she's like, what? I'm like, well, you heard me. I said, I'm going to make it to 100. I said, so I'm well over 50% of the way done, but you're not just going to throw me out. I still have 40% left, probably. And she's like, oh, I never thought of it like that. And I'm like, well, there you go. Okay. So when we start thinking about these things, hey, take that into account. Groom, how many miles should I go? Don't think of it like that. Here's why. When you are hauling ginormous loads in your truck, and you're just huge loads all the way, all the time, you're going to wear them off faster than a person that just putts around town in their little minivan or their little Ford Focus or whatever. if you are not running around, ripping and stopping, ripping and stopping, ripping and stopping, hauling heavy loads, your brake's going to last a long time. Okay? How long? It just really depends, doesn't it? What things we're going to look out for. Okay? What things we're going to look out for? Oh, for crying in the mud. Where's my other one at? So here's my rotor, of course. I'm going to say this is my inboard pad. Here's my outboard pad. We're going to make sure they are the same thickness inside and outside. As time goes on, they should wear down the exact same. However, from time to time, we'll have a situation where the inner pad might be more worn down or the outer pad might be more worn down. And both of those are symptoms of a problem. And so we're going to talk more about that in the coming days, about what that symptom is, or what that's a symptom of, and then how to remedy it. Okay? You don't cry because someone got a cold. No, he's got a snotty nose. He's got a cold. You see, that's a symptom of a cold. Well, how do you fix a cold? Well, the next symptom of a cold, you just go to bed and feel better tomorrow. But other things, like we got to give you a shot or whatever, in this case, we have some different ways of curing these problems. Okay? But again, it's not very hard. And you're going to be looking at, in the coming days, probably just this week, again, we're just getting the intro to things, you're going to be looking at brake pads on a vehicle. And you're going to walk over and you're going to inspect them. And you're like, I think that's 60% brake life, Mr. Groom. Oh, I think that's 20% or whatever it happens to be. And we're going to chat about that. And we're also going to chat about, hey, where's the caliper at? Oh, you see that? Mm-hmm. And so on and so on and so forth. Okay. That's where we're going this week. Introduction to that. We'll also talk a little bit. We'll probably talk just briefly about drum brakes this week too, just kind of get introduction. It won't be this week, it'll be next week, I think, we start actually looking at doing a brake job, start working on some of that, start talking our way through some of these other aspects. All right. Thank you for your rapt attention.